Hi, my name is Arda Tanikyan, and today I'm going to talk about my elevator project, which is my senior project too. So, every time an elevator goes to ground floor or a random floor, the people wait. So, it's impossible to decrease this time to zero, but it's possible to minimize it. So, my project is about the minimizing this time, but first I have to give some information about the elevators to you. So, I can say that basically there are two types of elevators. So, the hydraulic ones and rope ones. In these days, hydraulic ones are not so used because they are not cost effective and they use too much energy to operate, which makes the bills go up. So I based my model on the roped elevator. And if I have to talk about some necessary tools, I used a guide rail which holds the cabin, one DC motor to run the system, the cabin, some pulleys, a strap, switches, motor driver, and I needed a microprocessor to write my code, write my algorithm, and I used Arduino for it. So, the basic action schema is like this. As you can see, the electric motor is at upside. There are two pulleys. The strap is right at the system. There is a counterweight opposite at the cabin, and as you can see, when the cabin goes up, the counterweight goes down, and it's the opposite way. When the cabin goes down, the counterweight will go up. So, if I have to talk about my time efficient system, when usually at the system, when the cabins are free, it stays at their floor or it goes automatically to ground zero. But at my system, imagine an apartment with 5 floors and 2 elevators, and when both cabins are free, one cabin will go automatically to the first floor and the other one will go automatically to the 4th floor. So, for example, when a guy at 5th floor calls the elevator, the one at the 4th floor goes up and it will be time efficient. Another specialty is that, for example, usually people go to work at early morning. For example, from 7 a.m. to 9 a.m., the cabins will stay at upwards floors because the people will go down from the upstairs, and from the same logic, I can say that they came to home from work at 6 to 8 p.m. The cabins will stay at the ground floor to save time. And there will be a waiting time at the floor. This time will be limited so that one person will not block a cabin for a long time. This project was a 2-semester project which my professor gave to me. So at my first semester I built my model, my elevator model, and this was a 2-floor model. So for the second semester, now I'm making the second model, and the most most difficult part of my system is the algorithm part. So I have to write the algorithm, and my final delivery date is at June. So by the start of June, I will finish my project. So here are my references, and feel free to contact me. Thank you for listening.